Good afternoon, everyone. I am Karen Domingo, and I and my group mates will be discussing about the hurricane this afternoon. Before we begin, I will first ask a question about the hurricane related to hurricane. Do you think we are seeing more or fewer storms every year? To answer that, it is because um, Philippines is seeing a slight decrease in the total number of storms annually, but it is experiencing an increase in the intensity and destructiveness of the storms, particularly yung mga signal number or frequency. Meaning, hindi nagre-range lang up to 20 typhoons ang dumadaan sa Philippines, but when it comes to intensity and destructiveness, malakas siya. Umaabot yan ng signal number 5. Bakit kaya? It is because the Philippines sits in the Western Pacific typhoon belt region with consistently warm ocean waters and the atmospheric conditions, ideal for cyclone formation. This report focuses on tropical weather systems, specifically hurricanes. We will be discussing about how they form, how it behave, and how it evolved. Understanding these systems is important because hurricanes affect millions of people every year. So here are the scope of our discussion. First is the tropical weather and the origin of the hurricane. Next is the anatomy of hurricane, its formation and development, its movement and dissipation, or known as the when the storm dies out, its comparison to middle latitude cyclones, the classifications and naming, and of course the forecasting techniques. At the end of this discussion, there will be 5 guide questions for you to answer and will be submitted next meeting. Start with a definition of a hurricane. Hurricanes are the intense tropical cyclones characterized by strong winds, heavy rainfall, and low pressure center. Depending on location, they are called typhoons in the Western Pacific and cyclones naman in the Indian Ocean. Despite different names, they are the same type of storms. Next is the anatomy of a hurricane. There is an eye, the eye wall, and the rain bands. I know we are all familiar naman kapag sa itsura ng bagyo since we have the natakal na ito kung ano yung itsura ng bagyo and ano yung rotation niya. Sometimes ang rotation ng bagyo is counterclockwise or either clockwise. Counterclockwise siya kapag nasa northern hemisphere and clockwise naman siya kapag nasa southern hemisphere. And when it comes to the anatomy, yung eye niya, yung nasa gitna, yan yung calm center with the lowest pressure. Next is the eye wall. Yan yung pinakamalakas kung saan nandoon yung strongest winds and the heaviest rains. Then the rain bounds ay yung tinatawag natin na buntot ng bagyo is the outer spiraling thunderstorms. Usually, hurricanes movement is umaabot ng 74 mph or 74 miles per hour. Now, when it comes to the formations and the development of the typhoon, as you can see in the image, first feature is the early stage. The warm, moist air rises from the ocean surface, starting at the heat of 80 Fahrenheit. That heat causes the air above the water to rise and becomes moist. So in the next image, yung sa ikalawa, is the rising air creating the storm clouds. Paano nangyayari yon? Yung as the air cools down and forms clouds, more air rushes in at the bottom to replace, and the cycle continues. So, the storm, or it fuels the system even more. Ano nga pala yung clouds na napo-form? Yan yung cumulonimbus clouds. The third one is when the winds begin to spin. What causes that? It's because of the rotation of the earth, yung tinatawag natin na Coriolis effect. I know you are all familiar with Coriolis effect since natakal na siya ng other group. Because of that, the storm begins to form and the eye eventually becomes visible. Lastly is when the storm grows and strengthens. Kaya nga sinasabi ng mga matatanda, di ba, na mas nakakatakot kapag may bagyo pero mainit ang panahon. It is because when the storm stays over warm water and there's a little wind interference, the storm gets stronger and eventually becomes a hurricane. Next is about the stages and the development naman of a hurricane. The stages of a hurricane development are primarily differentiated by the wind speed, organization of air circulation, and the presence of the features like yung center or yung tinatawag natin na eye. First is the tropical disturbance. Yan yung mga disorganized thunderstorms with only slight wind circulation, and it has a low potential for damage. As you can see in the example image, yan yung effect ng tropical disturbance na less than 23 mph or miles per hour sustained winds niya. Second is the tropical depression. Yung maximum sustained winds niya ranging from 28 to 38 mph, wherein yung storm expands and develops a defined counterclockwise with circulation, and the low pressure center is mas organized na, and yung circulation niya is mas defined na. The third stage is the tropical storm. Its sustained winds range from 39 to 73 miles per hour. Dito, mas organized na talaga siya and may more circular shape na. Dito sa stage na to, yung storm is given a name to aid the tracking and the preparedness of people. So, the last stage na is yung naging na siyang hurricane. Na that's when the system reaches maturity with a well-defined eye at its center. Yung sustained winds niya is 74 miles per hour or mas mataas pa. Kapag nagla-landfall ito or tumatama na sa isang area, may possibility na maging zero visibility yung paligid. Though once the hurricane makes a landfall or moves over a colder water, it loses energy source, yung warm ocean water na nagsisimulang that's when nagsisimulang mag-dissipate or mag-decay or humina yung bagyo. Next naman is yung hurricane movement, no? Guided by the global wind patterns and the Coriolis effect, no? Sa northern hemisphere, hurricanes typically moves westward pushed by the trade winds. As they encounter the high pressure system and mid-latitude westerlies, nagsisimula itong mag-curve poleward and eastwards. Also, yung jet streams and these trade winds can influence their path, either steering the storm or slowing it down. Kayang mapabilis or mapahina yung pag-move ng hurricane, resulting in biglaang pagbabago ng direction ng bagyo. And because of that, hurricane tracking is important because maliit na pagbabago sa direction can make and result to a huge difference in impact. That's all for my report po, and the next topic will be tackled by Miss Kayla Ayalin, which is the dissipation or yun ngang when the storm dies out. Thank you.
So now let's come to hurricane dissipation. So how does a hurricane weakens? So in this slide, it explains why a hurricane loses its strength. Hurricane needs warm ocean, water, and stable condition to stay powerful. So when this condition change, the hurricane begins to weaken or dissipate, or means it slows down. So here are the points that how does the hurricane dissipate. So number one is that it moves over the land, cutting off the warm ocean energy sources. So when it moves into the land, the hurricane is cutting off. Why? Because hurricane gets their energy from the warm water. So when they move into the land, they no longer have this heat and moisture. So they start to weaken. So the longer the hurricane stay in the water, the stronger the hurricane is. Number two is that if it enters cooler water, so cooler water does not provide enough heat to fuel the hurricane. So without warm water, the storm slowly dies. So third is that it encounters high wind shear which disrupting the circulation. So when we say wind shear means the strong winds blowing into a different direction or speed at a different heights. When we say wind shear nga, it likes a circulating winds that has a different direction. So it breaks the hurricane's organized spin and causes it to fall apart. Kasi they are collision. The winds are having a collision because they are not circulating in the same pattern. So number four is that it becomes a tropical depression or remnant low. So as the storm weakens more and more, it is downgraded into a weaker system with a lower wind speed. So when we say a tropical depression, it still has a raining thunderstorm, but it is more lower than the typhoon or hurricane. Now let's come to the comparison of hurricane and a mid-latitude cyclone. So in this table, it compares two different types of large storm, which is the hurricanes and the mid-latitude cyclone. Although both are cyclonic storm, but they are formed in a different places and the different source of energy and structure. So in the wind flow, both storm rotate at the same rates, which is the counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. So this rotation is caused by the Coriolis effect. So the second is the strongest winds. So the strongest wind in the hurricanes are near at the surface or around the eye wall. So as Karen discussed, eye wall is in the middle of that hurricane. So the strongest wind of the hurricanes is around lang siya sa eye wall. So the middle latitude cyclone has a strongest wind around aloft or higher in the atmosphere, usually in the jet stream. So it is in the troposphere, yung pinaka strongest winds. So number 3 is the surface pressure. So hurricane and middle latitude cyclone has a both lowest pressure at the center. So this low pressure pulls air inward, causing storm rotation. So parang yung low pressure of air is napapadoon sa inward, that causing a storm rotation. So now let's come to the classifying of the hurricane strength. So to evaluate the possible damages that a hurricane has done, there are two persons that develop on how to estimate or to measure kung gaano ba kalakas yung wind ng isang hurricane. So, this scale is what we call Sahr-Simpson scale. And it was developed during early of the 1970s. So, there's two persons that I'm mentioning is Herbert Safer and Bob Simpson. So, the original Sahr-Simpson scale used a hurricane central pressure as a measure of storm's wind strength. So, the Sahr-Simpson scale is the one that provides extensive information for each category on the potential harm to people, pets, homes, structure of the building, or mga objects. So, this category is categorized into 5, which is the category 1, 2, 3, 4, 5. And in the first slide, you can see that the wind in 1 minute sustained. So, in the category 1, it is 74 to 95 milli per hour, and the kilo per hour is equivalent siya sa 64 to 82, which causes a very dangerous wind. And the category number 2, it has a milli per hour, that is about 96 to 110, and the kilo per knots is the 83 to 95, that will cause extremely dangerous winds. And the category number 3 is has a 111 to 129 milli per hour, that will cause a devastating damages. And the category number 4 has a 130 to 156 milli per hour, that will damage the house, a catastrophic damage. And category number 5 is greater than 156 milli per hour, that will also cause a catastrophic damage, but it is more stronger than the category number 4. So in the next slide, you can see that it has a visualization, or we can try nating mas maintindihan natin kung ano ba yung effect of each categories. So, in the category number 1, as I said nga, magkakaroon siya ng damages but not too extreme. Yes. So, as you can see at the picture, the house has a damage. Like the trees is damaged, the roof, the power line, causing short-term outrage lang, short-term. So, in the category number 2, as you can see, because of the dangerous winds, it will produce an extensive damage to homes, trees, and infrastructure. So, nagkaroon na siyang damages which dapat talaga siyang i-repair na. As you can see at the roof, So, the category number 3 has, as you can see at the picture, naputol na yung trees. Yung roof is natanggal na, nag-fly away na siya. So, in the category number 4, catastrophic damage will occur, leaving only the most well-built structure. So, since nakita nyo, yung poste ng kuryente is nawala na, and some part of the house is still there, but as you can see, it is ruined na. It is livable. So, sabi nga dyan, so yung mga stronger structure lang ang matitira. So, in the category number 5, which is the highest category, you can see wala ng structure, or it is completely destroyed. Yung poste, the trees, and the house. So now let's come to the naming of hurricanes and the tropical storm. So before hurricanes and tropical storm were assigned name, so ang ginagamit lang muna ng mga researcher, mga expert is they identify the hurricanes through its latitude and longitudinal. But at a time pass by kasi nagdadami na yung tao, the climate is changing. So, during 90s, nagkakaroon ng 2, 3, 4, 5 hurricane. So, nalilito na sila. Kung ano ba nung name ng isa, nung una, paano yung pangalawa, pangatlo, pang-apat. So, they cannot identify this 4 typhoon because walang name siya. So, starting 1950, nagkaroon na ng name but the naming is alphabetical. So, A to Z, seasonal siya. Like winter to ganito, A to Z siya. So, the whole year, alphabetical ang naming. So, after that, during 1953 to 1977, nagkaroon na ng they use female name, only female name, but after 1978, nagkaroon na ng assigned name which the researchers assign that the name should be alternate to female and male. So, at the next slide, you can see examples of naming that happened during 2017 at the hurricanes at the North Atlantic. So that's the example of naming of hurricane, or that's that hurricane that passes in the North Atlantic. So now let's come. So, before I give the stage to Miss Desiree Camba, I have a picture in here showing how the water level rises when it has a different factors. So as you can see, the main sea level is at the average water level of the ocean on a normal day. So, yun just a baseline from which all other increases are measured. So, after an hour, a day, or something, so as you can see, yung nagkaroon siya ng high tide, which increases the water level as a 2 feet. So, when the hurricanes arrive during high tides, the water is already 2 feet higher than the normal. So, this makes the flooding worse because the sea level start to rise or higher. So the other factors is the storm surge. So as you can see, it added 15 feet that it is the highest feet that rises. So when the hurricane strong winds pushes ocean towards the water, so nagkaroon siya ng 10 feet, and this image, the storm surge add 15 feet on the water on the top of the high tide. So yung winds is pushing the ocean water towards the land, kaya siya nagkaroon or nagdagdag ng 15 feet. So another factor is the waves that added 10 feet. So on the top of the storm surge, nag-added siya ng 15 feet. It is the largest wave pile, even more water. So totally, the water level rises 27 feet above the sea level. So that are the factors that make the land or the community flooded. So I will now give the floor to Miss Desiree Camba.
In this part, I will discuss the forecasting techniques that the meteorologists use to predict the hurricanes. But before the discovery of the hurricane equipments and techniques, the people are lack of awareness and preparedness whenever there are upcoming hurricanes. So it causes a lot of damages and kills a lot of lives of the people. The first discovery is we use the satellite observations. In 1960, the satellite's forecasters were almost blind over the ocean. Hurricane could form far from land and surprise coastal cities. But everything changed when the TIROS-1 was launched. It is the very first successful weather satellite because for the first time, the scientists saw the real pictures of storms from space, and they discovered the spiral cloud bands, the structure of the eye, and the early storm formation over remote oceans. And this revolutionized the forecasting techniques. Second one is the Hurricane Hunter craft. Accidentally na-discover siya ni pilot Joseph Duckworth and he proved that we can use aircraft to directly measure the hurricane. And pinangalanan siya bilang isang hurricane hunter because they discovered the structure of the eye, the pressure drops that predict strengthening, and also the exact winds na mas better and most accurate way to understand the hurricane strength compared doon sa satellite observation. So these are equipped with scientific instruments. The aircraft collect data from inside the storm, something satellites cannot do. They drop devices called drop sondes, which float down to the ocean surface while measuring temperature, pressure, humidity, and wind speeds at different heights. Third one is the weather radar. So, the radar was originally invented in World War II. Ang purpose niya is to detect the enemy's aircraft. But, operators began noticing something strange, that na-show sa screen yung storms. So, scientists realized that radar waves bounced off raindrops, revealing storm shapes. By the early 1950s, forecasters used radar to track the rain bands, the storm rotation, and the landfall timing. So this provides the real-time data on precipitation, storm development, and wind patterns, which enables early warnings for severe weather events like tornadoes and hurricanes. This also allows for disaster preparedness, improves the safety of activities like aviation, and provides valuable information for agriculture and daily planning. Fourth one is the buoys and ocean instrument. So when a hurricane forms, it gets its power from warm ocean water. That means scientists need to know exactly what's happening on and beneath the surface of the sea. To gather the information, a wide network of buoys, floating sensors, and underwater instrument is spread throughout the ocean. So many of them belongs to NOAA's National Buoy Network, which covers large areas of the Atlantic and Pacific Oceans. These devices constantly measure things like sea surface temperatures, wave height, ocean currents, wind, and air pressure. Forecasters rely on this data to understand whether the environment is helping a storm grow stronger. For instance, very warm water and high humidity can fuel rapid intensification, while cooler water can weaken the storm with the real-time buoy readings. Scientists can track these changes and make more accurate predictions about the hurricane path and strengths. Number 5 is the computer forecast models. It is also called as the numerical weather prediction models. It is used as a powerful computers to simulate how the atmosphere and ocean will behave. So this is like a super-powered weather simulators that help scientists predict where a hurricane is headed and how strong it might get. They gather tons of information from satellites, aircraft, ocean, buoys, and radar, and feed it into computers that use the physics to recreate what's happening in the atmosphere. Models such as GFS, ECMWF, and HWRF. Then run many different scenarios to show a range of possible paths and intensities. Forecasters look at all these results together to spot patterns and decide which outcome is most likely. Number 6, the historical data and climatology. Finally, the forecasting also draws on the long history of past storms. Climatology helps the meteorologists to understand the typical behavior of storms in certain regions during times of year. So the historical data can reveal the most common hurricane tracks, the typical intensification patterns, and which regions are most vulnerable, and also the seasonal variations in storm formation. For example, storms in the Atlantic often curve northward along similar paths to prevailing winds and ocean. By comparing current storms to similar past systems, scientists can better estimate what might happen next. So, climatology doesn't replace real-time forecasting tools, but it provides essential context that improves long-range predictions and seasonal outlooks. Meteorologists researches some ways to modify the hurricanes, and these are some of the examples on how to modify hurricane. Number 1 is the cloud seeding. So it is a weather modification technique designed to encourage clouds to produce precipitation, which are the rain or snow when they might not do so naturally. So clouds contain tiny water droplets or ice crystals. Often there's plenty of moisture, but the droplets are too small to fall as rain or snow. So cloud seeding adds particles called nuclei that help these droplets grow larger until they become heavy enough to fall. In cloud seeding, they uses two main types of substances, which are the ice nucleating agents, or most commonly used is the silver iodide. It is a crystal structure that is similar to ice. This helps supercooled water droplets. And the second is the hygroscopic or water attracting particles. Often ginagamit is yung mga salt particles like sodium chloride or potassium chloride, used mainly in warm clouds. These attract the moisture and help droplets merge and grow. So this cloud seeding technique cannot totally modify the hurricane, but it also helpful for increasing the rainfall in dry regions, boosting snowfall for water supply, and typically increases 5 to 15%, sometimes more under ideal conditions. This works only if clouds already contain enough moisture. This cloud seeding technique cannot create hurricanes or stop severe storms, so it is not so effective when it comes to modify the hurricane. So, no evidence that it can control large-scale weather patterns. Another ways and ideas they propose to modify hurricane is the pumping of cold deep water to the surface or upwelling system. So these are proposed devices, which is large vertical pipes powered by waves or pumps that would pull cold water from 100 to 200 meters below to the surface to mix with warm surface water. But the issue here is it requires massive infrastructure and warms back up weakly. And also, it disrupts the ecosystem. So, basically, nag-failed rin ito. And this method shows how ocean cooling could be attempted in theory, but none are used operationally, and all face prohibitive scientific, environmental, and logistical challenges. Number 3, using barriers or mechanical devices to physically disrupt a hurricane or cool the ocean. So, Those are the ideas that have been proposed but not feasible. And the first is the floating barriers to block warm water. Some proposals imagine huge floating walls or curtains to block warm surface water from flowing into a storm or to force mixing with deeper cold water. So, conceptually, they think that the barrier would separate warm surface water from the storm's path, or it would push warm water aside so cooler water mixes upward. But it doesn't work because tropical storms influence water over hundreds of kilometers, and any barriers are strong enough to withstand hurricane waves 10 to 20 meters high would need to be impossibly large and robust. The ocean would simply flow around or over this structure, and the environmental disturbance would be huge. They also tried the mechanical disruption of hurricane winds, which these devices would try to slow wind or disrupt the storm's organization. But it doesn't work again because hurricanes release energy similar to 10,000 nuclear bombs per day. No mechanical structure humans can build would survive the conditions, let alone affect the storm. And local disruption wouldn't matter because the system is powered by massive atmospheric and oceanic heat flows. So the bottom line of this is the barriers or mechanical disruption of the ocean or atmosphere cannot meaningfully affect hurricanes. The scale, energy, and the environmental risk make this concept impractical with current or foreseeable technology.
Thank you for listening, and here is the submission for the next week, which is the guide questions.